This video is a hands-on demo of WaferTools, a toolkit developed by the Lichtman Lab at Harvard University for automating wafer-related steps in connectomics projects. It covers section segmentation, ROI registration, section ordering, section visualization, and rough alignment. WaferTools is fully open source. You can find the repository on GitHub. After you download and unzip the package, you'll see wafertools.app. Double-click to launch. The app will open your terminal, automatically check for required packages, and install any missing ones. By default, it needs an internet connection, but we also provide an offline installation method on GitHub. When setup finishes, you'll land on the WaferTools interface. First, upload the wafer images you want to segment. Then choose a model, heavy, light, or lighter, to match the difficulty of your dataset. In most cases, light works well for the majority of wafers. Here, to demonstrate the upper bound of segmentation speed, I'll choose heavy. Next, there's an expected sections field. You can leave it blank or enter a number slightly larger than the true section count to help ensure full recall. Then choose either load cache or run new detection. If you've segmented this wafer before, load the cache. If no cache is found, the system will rerun segmentation automatically. For this demo, I cleared all caches and tested on a MacBook laptop without a GPU. Segmenting one wafer takes about 40 seconds. On a GPU machine, it typically completes within 20 seconds. You may see some false positives. You have two options: adjust the filter bar to remove outliers, or keep them and clean them up in the next stage. I'll keep them for now and export all section information to a CSV file. Next, go to Mask Unification and Alignment. Upload the wafer PNG we just segmented, and then upload the CSV we saved in the previous step. Results for the same wafer are automatically organized into a time-stamped folder. After import, the software checks the area distribution of the sections. If it passes, the system automatically selects a best-shaped section as the template. Otherwise, you can select one manually. Click Unify All Masks. After about 1 second, all sections are unified to the template shape. At this point, section orientations and region of interests have been restored. You can deselect any sections you don't plan to image, and you can also click to remove the false positives from earlier. Then, confirm and export the final region of interest information and import it into your imaging system for image acquisition. Now we'll recover the section order. Click Section Sequencing and point to the image path generated from our region of interests. Click Scan. Here we detect 94 PNGs. The default parameters work for most datasets. You only need to adjust CPU workers based on your machine. Here I'll set it to 8. Click Run Sift Pairwise Alignment. After about 50 to 60 seconds, you'll get a pairwise matrix in CSV format. Import it into Step A. Clean raw pairwise CSV for a quick cleanup and check. Then load the cleaned CSV into Step B. After about 1 second, you'll get the final ordering. The result is automatically saved as a .txt file in the folder, and you can also copy the ordering directly from the software. Finally, go to Order Visualization. We provide multiple visualization options. Feel free to explore and choose how you want to review and save results. For example, if you set the image path and load the ordering file, you'll get a roughly aligned EM stack in about 2 seconds. WaferTools will continue to be updated on GitHub, with upcoming features such as smart acquisition, electron microscope images compression, and 2D and 3D segmentation. If you have any questions about installation or usage, please reach out on GitHub.